All right, so today in class we talked about exponential growth. Now today we're talking about decay. All right, again, and starting with our formula, again it's an exponential function. All right, and A is still our initial amount. All right, so A stays put. It's still our initial amount, what we're starting with. All right, R is still my rate, but this time it's a percent decrease. A percent decrease instead of an increase. All right, and then we have our T, which is our amount of time. Amount of time. Again, those units are whatever the problem is referring to. Now, yesterday I talked about them always growing because we had 1 plus our rate. Well, now our quantity is 1 minus r. So we refer to that as our decay factor. So we now have our growth factor and our decay factor. All right, so it's actually very similar to yesterday's lesson, but now we're talking about how things go down over time. All right, they decrease over time. And we're going to focus a little bit more on the graphs and the calculator today, since it's a lot of the same topics. All right, so you buy a new car for $24,000. That's a nice car. Okay, the value Y of the car decreased by 16% each year. All right, and cars actually depreciate in value quite quickly. All right, so write an exponential decay model for the value of the car. Use the model to estimate the value after 2 years. So we know my initial amount, I bought it for $24,000. It says it's decreasing at a rate of 0.16, and the time is 2 years. All right, so it says write the model first. So we got Y equals 24,000 times 1 minus 0.16 to the t power. All right, that's our model. Now to find it for 2 years, we got Y equals 24,000 times the quantity, 1 minus 0.16 squared, because it's 2 years. So what does that give me? 24,000 times 0.84 squared gives me 24,000 times 0.7056. Salman Khan's rubbing off on me. I keep erasing. All right. So when you put that in your calculator, you should get a value of $16,934.40. So the car depreciated quite a bit. You bought it for $24,000. Now if you want to turn around and sell it after 2 years, you can sell it for about $17,000. So you would have lost $7,000 already. All right, so it's interesting. Now, part B says, graph the model on your calculator and sketch below. Describe the window you used. So the model is our equation from right here. All right, so let's take out our calculators. All right, we're going to graph that. So we have Y equals, all right, what's our model say? 24,000 times, you can do 1 minus 0.16 or 0.84, either one is appropriate, raised to the x power. All right, I'm going to hit graph. All right, and graphing. I don't see anything. All right, so how I like to start is I go zoom, and I go down to zoom fit, because a lot of times when we're dealing with these big numbers, we're not really sure where this graph exists quite yet. Once we get used to it, we'll find it. So zoom fit, excuse me, and we take a look at that graph. All right, and that's my graph there. All right, so let's draw a quick sketch of that. So I have my x and y axis, and my graph is depreciating over time. It seems to be approaching there. Okay, now we're not sure where it crosses or what it is yet. We're not sure where it's crossing or what it is yet. So let's look at the window. If you go to the window, notice that my Y min is at up over 4,000, and my Y max is up over 13,000. All right, so we're actually looking at just the positive axis. We can't even see, okay, our axis there. All right, so the next part of the problem says, use the graph to estimate when the car will have a value of $12,000. Well, 12,000 does fall between this range. All right, again, the shortest, we're at 4,000 at the bottom, and the top is at 13, 14,000 about. So at 12,000, so I'm going to go to my y equals menu, and in y2 I'm going to type 12,000, and I'm going to graph. All right, notice 12,000 is all the way down here, so in that little space there we're approaching the axis. So I want to know where my car is, how long, all right, what value of t, what value of time will my car be worth $12,000. So we're going to calculate that intersect. So second, calculate. Intersection is number 5. My first curve, all right, we're on the exponential function, enter. Spidey jumps to the other, my horizontal line down there, enter. And then we don't need to guess. And it brings us to 3.975, 12,000. So when y is 12,000, x is 3.98. When y is 12,000, x is 3.98. And in my function, okay, x is my t value. So after 3.98 years, because that was my t value, years, your car is worth $12,000. So you bought it for $24,000, and after about 4 years, it's lost half of its value, and that's what it's saying. So when it said describe the window, we're going to go zoom fit, and in your description, we would talk about how we had very large positive values. All right, we were between very large positive values, and my graph existed in our picture there, so that you get a sense of understanding that this isn't really the axis we were approaching. All right, the axis was actually all the way down here. All right, and the calculator can be a little tricky, so we'll take some time in class tomorrow, and we'll type this in and talk about fixing our window and making sense of it a little more. But you should get a solid grasp on that based on the work we've already done. Okay, let's go to the back. Okay, so there are 40,000, homes in your city. Each year, 10% of the homes are expected to disconnect from the septic systems and connect to the sewer system. All right, that's a good thing. So it says, write an exponential decay model for the number of homes that still use septic. Use the model to estimate the number of homes using septic systems after 5 years. All right, so we got our model. We have y equals my initial amount. Well, there's 40,000 homes. All right, it's a decay, so it's 1 minus, we're going down, 10% each year, raised to the x power, or the t power. Sorry, let's say t for time. And then they want you to figure it out, 40,000, 1 minus 0.10 to the 5th power. Okay, now, I want you to find the solution on your own, either pause it or come back to it later, and I want you to sketch the graph on your own. Okay, so solve on your own and sketch the graph on your own. Really practice what your window's doing and changing that, so go zoom fit, and then go to your window key and measure your window. Write it down. See what you're working with. And we'll talk more about part B tomorrow. That's where we'll start. All right, but I wanted to take time to do the next example because this one's a little different. So that one's similar to our first one. Make sure you take the time and finish that because I will be checking tomorrow. All right, and then in this one, it says, your car is now worth $5,000. You bought it 6 years ago and you expect it to depreciate 15% each year. How much did you buy the car for originally? So they actually want to know what A equals. What was the initial amount you paid? If now it's worth $5,000, right, we're looking for A. We bought it. It depreciated 15% each year, so 1 minus 0.15. Right, and it was 6 years ago, so my time is 6. All right, so they want us to solve this equation for A. So 1 minus 0.15 is 0.85 to the 6th power. Put that in your calculator, 0.85 to the 6th power. And you get 5,000 equals A times this big crazy decimal. 377.1495156, dot, dot, dot. It goes on and on. All right, remember we talked about this in the notes yesterday. All right, I want you to take 5,000 divided by, and in your calculator, all right, just put second negative for that answer. And when you hit enter, you should get this result, 13,257.34 Now, with these problems, you should always take a look at, does my answer make sense? Well, I bought it. It's now worth 5,000, and I bought it for this. Over 6 years, does it make sense to go down about a little over $8,000? Yeah. Based on what we saw already, this number better be higher. Okay, if your car's worth 5,000 and you paid less for it 6 years ago, you got quite a deal. So that number should be larger, and that makes sense in context of the problem. So make sure you finish part A and B, and we'll see you tomorrow morning. Thanks.